integral. So in the complementary function, we have seen the four cases depending on the nature of roots of a complementary function, auxiliary equation. So the first is a case if roots are real and distinct. Second is if roots are real and equal for a complex root and complex repeated root. So these four cases we have discussed. Hope you have solved some examples related to this. Okay, I have explained some examples. So try to solve more and more examples so that you can understand it in better way. So today we will discuss what is the particular integral. So see, to find out the particular integral, basically just consider first, consider the nth order linear differential equation in the form of operator d. Phi of d into y is equal to fx that we have. Now we are interested in yp, so therefore yp is equal to, take the inverse reciprocal of this, phi of d into fx. Okay, so call it as equation number one. So now we use this expression, equation number one, to find out the particular integral. But there are three methods. There are three methods to find a particular integral. So see them one by one. So the first method is a general method. Okay, the second is, it is very simple and important, it is shortcut method. And third one is what? It is method of variation of parameter. Third one is method of variation of parameter. So these, this is also called as MVP. So these methods are very important. Okay. So see, generally this first, in this first method, general method, so there are some laborious and difficult integration. So that's why we just avoid it. But we will discuss definitely that. Okay. So first of all, we will see the shortcut method. So what is there in the shortcut method? Okay. So let us see that. What is the shortcut method? Now, first method is the shortcut method. We will discuss first the shortcut method, and then we'll discuss the method of variation of parameter, and finally we'll discuss the general method. Okay, so what is there in the shortcut method? So depending on nature of function, so from equation 1, depending on nature of function fx, we have different cases. We have different cases for shortcut method. Okay, and what are that actually the cases? Let us see them one by one. So case 1. Okay, these cases are very important. Case 1. So if my fx is equal, is of the form e raised to ax. Okay, means what? If here it is e raised to ax, whatever a may be constant, positive, negative, whatever that. Okay, so if fx is equal to x, then what is my yp in this case? So therefore my yp is equal to, yp is equal to 1 upon phi of d into e raised to ax. Now what we have to do? We have to replace this d by a, phi of a into e raised to ax, provided that phi of a is never 0. Okay, what we are doing here? So this is replace e by a, provided that phi of a is not equal to 0. But in some cases phi of a may be 0. Then what? Okay, so if phi of a is 0, so if phi of a, this is equal to 0, then case fail. Okay, our case fails, and in that case, what is my yp? So yp is equal to what? Now multiply by x, take the derivative of phi of d, it is phi dash of d into e raised to ax, and now replace d by a. Okay, here, so by taking the derivative of phi of d and then replace d by a, so this is nothing but what? X divided by phi dash of a into e raised to ax, again provided that this phi dash of a is not equal to 0. If it is 0, then again case fail. Okay, so if phi dash of a is 0, then again case fails. Then what we need to do? We have this yp is equal to multiply by x square in that case. Okay, take the derivative of phi dash of d. This is phi double dash of d. Okay, into e raised to ax. Okay, and now replace this d by a here. Okay, isn't it? So this is equal to x square divided by phi double dash of a into e raised to ax. That's it. Okay, so see, in this case we just have to replace d by a. Whenever the case fails, just take the derivative and replace d by a in that derivative. That's it. Okay, now some another part of this case are also there, but we just need to understand example. Okay, so first of all, let us see the example to understand this. So what is the complementary function, sorry, what is the particular integral? Okay, we are just talking about the particular integral, so we just see the common examples after discussing all the cases to find out the complete solution. Okay, so now what is that? D square plus 3d plus 2 into y, this is equal to, suppose, e raised to 2x. Okay, now what is my yp here? So yp is equal to 1 upon, just write down this phi of d, so d square plus 3d plus 2 into e raised to 2x. Okay, now what we need to do? So case says that replace d by a. Okay, whatever your a, just replace it by sorry, our d, replace it by a. Okay, now this is our a, 2 is our a, so therefore replace d by 2. Here we are replace d by 2, and parallelly what we need to check? We need to check that whether by replacing that d by 2, whether that phi of d becomes 0 or not. If it becomes 0, then case fail, we need to take the derivative and then replace d by a. If it is not 0, then we don't have to do anything. That is the final answer. Okay, so now let us replace this d by a. So this is 1 upon d square, d means 2, I'm replacing this by 2. Okay, bracket square plus 3 into, what is d? D is 2. Okay, plus 2 into e raised to 2x. I have replaced this d by 2. Now check what is the denominator. 1 upon 2 square is 4, 3 into 2 is 6 plus 2 into e raised to 2x. And what is my final answer here? My final answer is, this is equal to 1 upon 6 plus 4, it is 10 plus 2 is 12. So 1 by 12 e raised to 2x. That's it. This is my final answer. This is my yp. See, this 12 is not equal to 0. No need to take the derivative. No need to check the failure of case. Okay. So this is very simple case to understand the shortcut method. And so you see, if in the online exam there may be a question like this. So what is the particular integral for this example? Okay. So this equation is given in the example. Okay, and we need to find out the particular integral. If they are asking for particular integral, you need to check for particular integral only. If they are asking for complementary function, you need to check only complementary function. And if they are asking for complete solution, then and then you need to check complementary function as well as particular integral. Okay, so just try to understand the difference between all these things. Okay, now see the example of failure of case. Okay, I will explain all the possible examples to understand this case. So find out the complement, find out the particular integral for this d square minus 2d plus 1 into y equal to e raised to x. Okay, so this is the example. Now what is the yp in this case? So yp is equal to 1 upon d square minus 2d plus 1 into e raised to x. Now what is my a? Here a is nothing but 1. Replace d by 1. Okay, now what I get? So this is equal to 1 upon 1 square. Okay, so 1 square minus 2 into 1. Okay, so this is 2 into 1 plus 1. e raised to x. See, 1 square is 1 minus 2 plus 1. It is 0. See here phi of 1 becomes 0. Case fail. Case fails. Now what we need to check? We need to take the derivative and then replace d by a. So therefore this is what? Multiply by x, take the derivative of phi of d. So this is my phi of d. Its derivative is d square. Derivative of d square is 2d minus derivative of 2d is 2. Derivative of 1 is 0 into e raised to x. Now replace d by a. Okay, so what is my a? A is 1. Replace d by 1. So therefore this is equal to x divided by 2 into 1. Okay, this is 1 minus 2. So 2 minus 2 becomes 0. Again case fails. So phi dash of 1 is also 0. So again case fails. Okay, and now what we need to take? We need to take the derivative one more time. Okay, so therefore this is equal to multiply by x square. Again take the derivative. What is the derivative of this phi dash of d? This is only 2. Second derivative into e raised to x. And now see there is no d to replace a, and that's it. Therefore this is my final answer. Okay, so this is the yp for this. Okay, we have seen both the equation, both the cases, both the parts. So if case fails, if case is not fails. Okay, so some notes are related to this case. Okay, hope you have understand this case. It is very simple. We need to just replace d by a. So some notes are here. Note that. What is that? First, so if fx is constant, suppose it is k, then what is my complementary function? Sorry, what is my particular integral in this case? Okay, then particular integral is yp is equal to 1 upon phi of d into k. Now that k we can write. Okay, how we can write that k? So that, see, e raised to 0 is nothing but e raised to 0 is nothing but 1. Okay, so we can add that e raised to 0 with the multiple of this k. Okay, so what I get then? 1 upon phi of d into k e raised to 0x. Okay, I can take that k constant outside. 1 upon phi of d into e raised to 0x. Now what is my a? 0. Therefore replace d by 0. That's it. Okay, and therefore what I get here? So k into 1 upon phi of 0 into e raised to 0x. So there is no need to write 0x. E raised to 0x is 1. Okay, and provided that phi of 0 is not equal to 0. So if it is equal to 0, then what? Then we need to check the derivative and then replace d by a, and a is not 0. So this is the case if it is a constant. So see the example for that. So this is d square plus 2 into y. This is equal to, suppose, 5. See, this is 5. Okay, now how we can find out the particular integral for this? Yp is equal to 1 upon d square plus 2 into 5. But this is k is 5 here, so this k is equal to 5. So as the case says that, so just multiply by e raised to 0x. So therefore 1 upon d square plus 2 into 5 e raised to 0x. Now we can take that 5 outside. Okay, and after taking that 5 outside, what I get? Just a minute. Okay, so this is equal to what? 5 is constant, take it outside. 1 upon d square plus 2 into e raised to 0x. Now replace d by 0. What I get here? So this is equal to 5, 1 upon 0 plus 2. 0 square is 0 into e raised to 0 is 1 also. And my answer is, what is my yp in this case? It is 5 by 2. Isn't it? So there is no x in this case. Okay, there is no e raised to, there is no nothing, no variable. Okay, so that's it. This is very simple part. So these type of questions may be there for online. It is very important. That's why I have explained this case here. That's why I have explained this method here. So one more note is here. uh, Suppose my second note, fx is equal to a raised to x. I'm not talking about e raised to x. This is a raised to x. This is somewhat different. Okay. Now here we have to just change this a raised to x or convert this a raised to x in the form of e raised to something. So how we can convert that in the form of e raised to? Okay. So before that, see yp is equal to 1 upon phi of b into e raised to, sorry, a raised to x phi of b. Now how we can convert this a raised to x in the form of e raised to something? So let us take y is equal to a raised to x. Take log on both sides. Log of y is equal to log of a raised to x, so that a comes in the front. So this is log of y. This is equal to x into log of a. Okay, by using the property of logarithm. And if we apply the definition of log, then what is my y? Y is equal to e raised to x into log a. Okay, because what is the definition of log? See, if log y is equal to x, then y is equal to e raised to x. This is the definition of logarithm. Okay, so if log y is equal to x, then y is equal to e raised to x. So this whole thing goes into the power of e. Okay, so this whole things x log a goes into the power of e. So see, y is equal to, we have taken a raised to x, we get y is equal to e raised to x log a. So definitely what we have, a raised to x is something e raised to x into log a. Okay, and we want that, we want the term in the power of e. A raised to x is same as e raised to x log a, and that's why we can write this as 1 upon phi of b into e raised to x into log a. And whatever the term instead of just avoiding x in the power of e, that should be our a. Now replace d by log a. Okay, so here what we have to do, replace d by log of a. Okay, so hope you have got this. Okay, this is very simple, and therefore what is my answer here? So I am replacing this d by log of a into e raised to x log a. E raised to x log a means not what, a raised to x. Now our work is over, of replacement work is over. Just replace that d by log a, and then after that e raised to x log a is as same as a raised to x. So this is my yp. Okay, let us see the example for this. Find d square plus 3 into y. Find a particular integral for this. It is equal to, suppose, 2 raised to x. Okay, now in this case what is my yp? Let's see, yp is equal to 1 upon d square plus 3 into 2 raised to x. But what is 2 raised to x? 2 raised to x is nothing but e raised to x into log of 2. Am I right? That we have seen earlier. Now replace this 2 raised to x by 1 upon d cube, sorry, d square plus 3 is there. This is e raised to x into log of 2. Okay, and now replace d by log 2. So this is equal to what? This is equal to 1 upon log of 2 square plus 3 into e raised to x log of 2. What is e raised to x log of 2? E raised to x log of 2 is nothing but 2 raised to x. Just replace that. Okay, substitute that value. So this is equal to 1 upon log of 2 bracket square plus 3 into 2 raised to x. Some student may just commit the mistake here. They just keep this to put this to in front of log 2. But don't do that, because see, log of 2 square, or in general if we take log of a raised to m, is not equal to log of a to the power m. These two things are different. Okay, so if log a whole the power m is there, then we cannot take this m in front of this log a. But in this case we can take, if that m is in the power of a only. Okay, so this is the difference. Now keep this as it is. So this is my yp, and that's it. This is the first case. Okay, so this is the first case for complement, sorry, particular integral with the help of shortcut method. Is there any doubt? Okay, so hope you have got this. Is there any doubt in the first case? If you have, you can please ask, otherwise we will move to the next case. Okay, so this is this very simple case for the shortcut method. One more thing is here for this method, sorry, for this case, just third note. Okay, and that note is, so simply if we have 1 upon d minus a into e raised to x, e raised to ax, d minus a, okay, so whatever that a, it is same in the power of a. Okay, so my answer is x into e raised to ax. Okay, so if 1 upon d minus a bracket square into e raised to ax is there, okay, so what is my answer? It is x square upon 2 factorial e raised to ax. If 1 upon d minus a bracket cube e raised to ax is there, then what is my answer? X cube upon 3 factorial e raised to ax. And in general, if we proceed with the same way, whatever the power of this d minus a, okay, so it is, and continuing in this way, 1 upon d minus a raised to n e raised to ax, this is equal to x raised to n divided by n factorial e raised to x. This is also a important note, because they may ask you in the online exam, what is the 1 upon d minus a cube e raised to 2x. So this is x cube upon 3 factorial, whatever the 3 factorial, you know how to find out the 3 factorial. It is with the help of calculus you can easily find out. It is a product of 1, 2 and 3. If 4 factorial, it is a product of 1, 2, 3, 4 and so on. Okay, so that's it about this. And now see the second case. I think there is no problem in the first case. Okay, see the second case, case number 2. So if my fx is case number 2, if my fx is equal to sine of ax plus b or cos of ax plus b. Okay, so out of these two, whatever it is, the procedure is same. So let us see that. So what is my yp in this case? Yp is equal to 1 upon phi of d square into sine of ax plus b. Okay, now what we are doing here, we are replace d square by minus a square. Just understand it properly. What we are doing, we are only replacing d square. If d is there, single d is there, don't try to replace it. Just try to obtain d square in the denominator. Okay, if d square is there, then we have to replace it by minus a square. Minus a square means what? If a is equal to 2, take its square, so a square is equal to 4, and then multiply by minus a square is equal to minus 4. Then in that case we have to replace d square by minus 4, isn't it? So we will discuss the example for the same also. Okay, so let me just complete this theoretical part. So d square replaced by minus a square, and what is this? We just have to replace d square by minus a square into sine of ax plus b, and same for cos. Okay, instead of sine you can replace also cos. Okay, provided that phi of minus a square is not equal to 0. So if it is 0, if phi of minus a square is equal to 0, then case fail. Then case fails. Then what we need to take? We need to take the derivative as that of previous. So in the previous case we have seen. So yp is equal to what? 1 upon. So just take the derivative of this, multiply by x, take the derivative of phi dash of minus a square, then replace this sine of, sorry, phi dash of, okay, replace d square by minus a square. So I have replaced this d square by minus a square, so sine of ax plus b. provided that phi dash of minus a square is not equal to 0. So if it is 0, again take the derivative and continue the procedure till you get the non-zero denominator. Okay, we want the non-zero denominator here, and similarly we can apply this for cos. Similarly, we can apply the same process for cos ax plus b. Okay, so same process we can apply for cos ax plus b. Okay, now see the example to understand this. Okay, example. Suppose if we take okay, d square plus 3d plus 2 into y equal to, suppose it is sine of 2x, or we can take cos 2x, suppose cos of 2x. Okay, now what is my yp here? So yp is equal to 1 upon d square plus 3d plus 2 into cos of 2x. Okay, now so case says that replace d square by minus a square. What is my a? So replace d square by a minus a square. A means 2, its square is 4. See, a means 2, its square is what? 4, and multiply by minus. Minus a square is equal to minus 4. Replace d square by minus 4 here. So what I get? This is equal to what? 1 upon replacing d square by minus 4. This is minus 4 plus 3d. Don't replace this d. There is no d square. Okay, just keep this d as it is. Plus 2. This is important. Okay, cos of 2x. Now just simplify this. What I get? 1 upon, it is simply minus 4 plus 2 is nothing but minus 2. So this is 3d minus 2 into cos of 2x. Now what to do? Because there is no d square in the denominator. How we replace this d square? And how we just uh, get this d square in the denominator? It is very simple process. You have to just follow this process in each and every example of this kind if d square is not in the denominator. So just what we have to do, just we have to take the rationalize the denominator. So how we rationalize the denominator? So this is 1 upon 3d minus 2 divide and multiply by 3d plus 2. Okay, this is 3d plus 2. In this way we will get the d square in the denominator. So what is this? A plus b, a minus b. What we have? A plus b into a minus b. This is equal to a square minus b square. This is simple formula from algebra. This is now in the numerator there is 3d plus 2. Okay, divide by, this is nothing but a square. See, 3d minus 2 and 3d plus 2 and 3d minus 2. This is equal to what? 3d square minus 2 square. 3d square is nothing but 9d square minus 4. Okay, so this is in the denominator, 9d square minus 4 into cos of 2x. Now we have to replace this. Now see, d square is there in the numerator. Okay, therefore replace d square by minus a square. So this is 3d plus 2 into cos of 2x divided by, we are replacing d square by minus a square, 9 into minus 4 minus 4. Okay, so this is 9 into minus 4 minus 4. Okay, so see, this cos 2x is multiple with bracket, so 3 into d cos of 2x plus 2 into cos of 2x. Okay, divide by what? Divide by, just calculate this, 9 into minus 4, it is I think minus 36, minus 4, it is minus 40. Okay, and just calculate the numerator. So yp is equal to minus 1 upon 40 in bracket 3 derivative of cos 2x. D means d by dx. Capital D means d by dx. Okay, D means what? Your d by dx. And therefore just take the derivative of cos 2x. Derivative of cos 2x is minus sine 2x into 2. So this is nothing but minus 2 sine of 2x. Okay, I hope you have derivatives. Plus 2 cos of 2x. So just revise all that results: derivative, integration, trigonometry. These three basic results are important. And just final answer is multiply by minus. So this is 1 upon 40 in bracket 3 2s are 6 minus minus plus 6 sine of 2x, and this is minus plus minus 2 cos of 2x. Okay, so that's it. This is my yp for this. Okay, so it is very simple, this case. Okay, so but here we don't have seen the case of failure. Okay, in some cases the case may be fail, in some example case may be fail, and what we need to do in that case I will just explain you with the help of example. Let us see that. So next example, so find out the particular integral for d square plus 1 into y equal to sine of x. Okay, so this is the example. Now see, yp is equal to, just try to attend the lecture within the first 10 minutes please. Okay, don't just I want to uh, hear everyone before 10 minutes. Okay, now 1 upon d square plus 1 into sine of x. Now what, see d square is there, replace d square by minus a square. What is a? My a is 1, its square is what? Plus 1, and multiply by minus. So this is minus 1. Now replace d square by minus 1. Got it? So what is my yp here? So this is 1 upon minus 1 plus 1 into sine x. See, case fail. Okay, so phi of minus a square is equal to 0. Therefore, case fail. Case fails here. And if the case fails, so we need to take the derivative. Okay, so just take the derivative. Multiply by x, take the derivative is 2d into sine x. But see, there is no d square in the denominator, but only 1 upon d is there. If d is a derivative, okay, then what is 1 upon d? It's reciprocal. It is nothing but integration, isn't it? So 1 upon d is nothing but integration. So therefore this is nothing but x by 2 as it is 1 upon d into sine of x. So it, what does it mean? It means what? Integration of sine of x. X by 2 into integration of sine x dx. 1 upon d is nothing but integration. So this is equal to x by 2. What is the integration of sine x? It is minus cos x. And that's it. This is my final answer. And therefore, in this case, my yp is equal to minus x by 2 into cos x. Okay. So, is there any doubt? Is there any doubt? Hope you have understand this. It is a simple question. Okay. Uh, this is the second case. So, we have seen the example for case fail as well as case if case is not fail. Okay, so hope you have got this. Let us move to the next case. Is there any doubt? Just you can please ask me. Okay, otherwise I will move to the next. Yes, is there any doubts? I just want to hear you if you have any doubt. Okay, okay, fine. Now let us move to the next case number 3. This case is similar to as that of first. Okay, sorry, as that of second. So if my fx is equal to what? It is sine hyperbolic ax plus b or cos hyperbolic ax plus b. Okay, so this is the, and the only change is what? So in the yp is what? So yp is 1 upon phi of d square into suppose sine hyperbolic ax plus b. Okay, now what we have to replace? The only thing is what? Replace b square by plus a square. This is the only change. In the previous case we have seen we have replaced d square by minus a square, but in this case we have to replace d square by plus a square. This is the only change. Remaining parts are as it is. Okay, So this is 1 upon phi of plus a square into sine of hyperbolic ax plus b, provided that phi of a square is not equal to 0. So if it is 0, then case fail. If phi of a square is equal to 0, case fail. So if case fail, we need to take the derivative, okay, and multiply by x. So therefore, in that case, my yp is equal to x divided by phi dash of a square into sine hyperbolic ax plus b. Okay, that's it. Provided that phi dash of a square is not equal to 0. If it is 0, then again case fail. You need to multiply by x square, take the derivative, and then replace d square by plus x square. So if it is d square is not there, then just try to find out the d square. If only d is there, 1 upon d, it means what? Derivative. Okay, so that in that way you can definitely find out the particular integral. Similarly, okay, so yp is equal to x upon phi of d square into cos of hyperbolic ax plus b. Okay, and this is what? This is equal to not x, this is not x, this is 1, this is not fails here, so this is 1 upon phi of a square into cos of hyperbolic ax plus b. A similar case for this, provided that phi of a square is not equal to 0. If it is 0, case fail, you need to multiply by x and all that things. Okay, I'm not explaining the example for this case because this case is same as that of before. Okay, so hope you have got this. Is there any doubt? Okay, fine. So let us move to the next case. So the next case is also simple. Suppose if we have x into v, sorry, x raised to m. The next case is what? If fx is equal to what? If fx is equal to x raised to m, the power of x. Then what is my yp here? This is very crucial case. So yp is equal to suppose 1 upon phi of d into x raised to m. Not single x raised to m is there. There may be a function like this. Fx may be x square plus x plus 1, like this in the right hand side. Instead of fx, there may be x square plus x. There may be a polynomial in x. Okay, so but we just take the particular case for x, general case for x raised to m. Now what we need to do here, just take this phi of d in the numerator. Okay, its power become minus 1 and x raised to m, and try to expand this with the help of the expansion. I want to give you the note that these two expansions are very important for solving this case. That what are that expansions? 1 plus y raised to minus 1, this is equal to 1 minus y plus y square minus y cube plus so on. And if 1 minus y is there, raised to minus 1, this is equal to 1 plus y square plus y cube plus so on. All the terms are positive. So these two expansions are important for solving this case. How these two expansions are important, let us see with the help of example. So the example is d square plus 1 into y, this is equal to suppose x square. Okay, now what is my yp in this case? Yp is equal to 1 upon, it is d square plus 1 into x square. Now case says that x raised to m is there, m is nothing but 2, take this in the numerator. So it become 1 plus d square. D square plus 1 is same as 1 plus d square raised to minus 1 into x square. Now this is of this form, 1 plus y raised to minus 1. What is my y? Y is nothing but d square. This is my y. Okay, and expand this with the help of this. Replace y by d square. So what I get then? So this is equal to what? 1 minus d square plus d square bracket square minus d cube bracket square. Sorry, d square bracket cube plus so on. Okay, bracket complete into x square. This is infinite term expansion. So 1 plus d square raised to minus 1. So hope you have got this. I have just replaced y by d square. okay, in this expansion. See how many terms are there in this expansion, and it is depend on what? It is depend on the power of x. How? See, the first derivative, d means derivative, so first derivative of x square is what? D of x square, this is equal to 2x. D square of x square, this is equal to 2. D cube of x square, this is equal to 0. D raised to 4 of x square, this is equal to 0. See, as this derivative is 0, upcoming all derivatives become 0. Okay, so we have the term only up to this. So this only first two terms are there in the expansions. This term becomes 0. This term also becomes 0, and remaining terms are also become 0. Okay, so I hope you have understand this. So this is only 1 minus d square rest into x square. So this is equal to 1 into x square is x square minus d square into x square. So second derivative of x square is nothing but 2, and therefore from this my yp is x square minus 2. This is my yp. Okay, so this is the simple case to find out this. Okay, now but every time this the example is not so not like this. Okay, but we need to just convert this. Okay, how we can convert that? So let us see. uh, Suppose the example is d square plus 3d plus 2 into y equal to x square, whatever that, x square x cube. I just take this x square for our purpose only. Now what is my yp in this case? Yp is equal to 1 upon d square plus 3d plus 2 into x square. But we want the denominator in terms of 1 plus something, but 1 is not there. See, in the previous example 1 is there, that's why we have directly write 1 plus d square, because we have these two expansion in terms of 1 plus or 1 minus. So 1 is important. Okay, we want 1. So how we get this one? Whatever the constant term is there, just take this common. Okay, so this is 1 upon, if I take 2 outside, then what I get in the denominator? It is, see, d square plus 3d divided by 2. Am I right? Okay, plus 1 into x square is there. Now I get 1 is there in the denominator. So see, this is nothing but what? 1 by 2. Now we can take this in the numerator. 1 plus d square plus 3d divided by 2. Okay, raised to minus 1 into x square, isn't it? And now what is my y here? So this is 1 plus y. See, this is 1 plus y. This is my y, this total y. And we can expand this with the help of like this. So 1 by 2 in bracket 1 minus d square plus 3d divided by 2 plus d square plus 3d divided by 2 square minus d square by plus 3d divided by 2 cube and so on into x square. And you need to check which are zeros and which are not zeros. Whichever are zero, just skip them, and if which are not zero, just take them in the consideration. Okay, and you will get the answer for this. Okay, so this is the fourth case. So remaining two cases are important also, that we will discuss in the next lecture.